If this is your first time viewing my Flat Earthers debunking video, well, this is a part of a series where I look at one of their flyer and go through one section at a time. So far we talked about their claim water is a natural level, airplane level flights, and science says stationary. If I remember, I'll put the links in description, but you can also find it from playlist. Today we look at their fourth claim, horizon is always eye level. Not only is the horizon is always flat to the observer, but it rises to eye level. High altitude amateur balloon footage without a fisheye or GoPro lens always shows a flat earth. Well, to be honest, it's often hard to understand flat earthers due to the amount of word salad they use. Also, English not being my first language, it's utterly possible that I got the wrong end of the stick. But this is what I understood from their explanation. Their whole claim is based on a formula 8 inches per mile squared. They believe this is how far a plane or a spot would drop on a round globe from current location given a distance in miles. So if you're standing on point 1 and there is another you standing 1 mile away, well, that clone of yours is standing 8 inches below you. In other words, if we draw a perpendicular line from top of your head, that line would be 8 inches higher than the clone 1 mile away. 2 miles away, that drop becomes 32 inches. 3 miles away, it is 72 inches, and so on. They argue that this means when you're looking straight, i.e., perpendicular to the force of gravity, or what they like to call down, then you should not be able to see the horizon, even if you look left or right. So even in this short description, there is a lot to unpack. We have to understand what horizon truly is and how it actually works. We will also find out that even on a flat earth, we would notice the same effect. The keyword here is linear perspective. And yes, it's a technique used by artists to create the illusion of depth and space, and it is similar to how the human eye sees the world. As long as it's not foggy, we can see a horizon at seaside. This is the line we see far away out to sea, where the water and the sky seems to meet. There are horizon lines everywhere, but usually we don't see them because of some obstacles in the way. And we always see the horizon line at our eye level. In fact, even if we stand up or sit down, the horizon line changes too and follows our eye level. If we stand on top of a very tall building or look out of a window of an aeroplane, the horizon is still at our eye level. It's only everything else that appears to change in relation to our eye level. The fact is that everything looks the way it does from our point of view because we see it in relation to ourselves. This is why from that top building, everything would look shorter because at that moment, we are higher than everything else. Our eye level is always on the horizon line because what we're really looking for is the edge of our planet where it begins to carve out of sight. At sea level, we see the horizon. When we are higher up, we still see the horizon, but we are just looking a bit farther over the edge of the earth. Now I completely understand that the explanation I just provided may not be enough. If only I could give you an actual demonstration. I know. Let's find a brick wall. Rows of bricks are usually parallel to the ground. The lines of the bricks that are below your eye level will be angled upwards. The ones at your eye level will be straight across, and the ones above your eye level will be angled downwards towards eye level. You also notice the further the line goes, it seems to get closer and closer. It's the same effect you'd get looking at a straight train line. They seem to converge. This point is also called vanishing point and is always on the horizon line. Back to our brick wall. Now crouch down, so another line of the bricks becomes straight across your eye level. Guess what? The lines below your eye level are still angled upwards, and the ones above are still angled downwards, and they all still seems to converge. On a small wall, you will be able to visually spot that the line is not at the same height, and often you would know that by using a background object as a reference point. But the longer the wall gets, the less prominent it becomes. You can now imagine a wall long enough where the convergence or vanishing point would appear to be the same spot even when you're crouching or standing up. Now, a completely flat earth is akin to one of those lines under your eye level. Pick any line on the wall and call it the surface of flat earth. Now pick any line above it. The vanishing point, which is always on horizon, would always be on your eye level. Because the earth is so bloody large, compared to our eyesight, this is the same reason why horizon is always at eye level. Now, for argument's sake, let's say you're still unconvinced. Okay. On screen you can see 3 simple diagrams, obviously not drawn to scale. So on a globe earth, the argument is eye level would be perpendicular and thus never see the horizon at eye level. Fine. What happens on a flat earth? That same argument would also mean you should not be able to see the horizon at eye level either. Well, what if it's not flat but concave? Well, if that was the case, with altitude, that viewing angle would change and it would definitely not be at eye level all the time. One thing to absolutely clarify here. I believe horizon always being at eye level neither proves or disproves round earth. Similarly, it doesn't prove or disprove flat earth either. There is explanation of why this happens, and hopefully from the wall example, we can also understand that it applies to flat earth as well. For all your clones who are standing 1 mile apart from each other, suppose that 8 inches per mile square is correct. So your clone 1 mile away is at a plane 8 inches lower than you. The clone 2 miles away is 32 inches lower. Okay. Now imagine that brick wall spanning all the way to the very last clone. Your eye level is straight to a line on the wall, and suppose that level is the same as an average male eye height of 1.63 meter, and the wall height is 2 meter. Your first clone? Well, he is your clone, so he has the same height and the wall is still 2 meter. How about the clone after that? The same deal, and the one after and the one after that. You and every single of your clone is looking at the very same line at eye level. Even if one of your clone decides to sit down and have a different line at his eye level, well, as we explained earlier, all these parallel lines will seem to converge at vanishing point or horizon. So you see the horizon, your clone sees the horizon, everyone else sees the horizon. For flat earthers to use this as a proof of a non-round globe, well, then they should also explain how it works on their model. I started with linear perspective. Well, let's look at a couple of images just for fun to see how our eyes and brain works. First, an image from Artifactory. Note how all the figures share the same eye level, which also happens to be the horizon line. This suggests that they are all the same height and are standing on the same plane. Because the horizon happens to be our eye level, it also suggests that the figures are the same height as any viewer of the picture. This is almost the same as our clones example. Now the same image with all the figures are still the same size, but their eye levels no longer have a relationship to the eye level of the picture. As a result, the scale of the figures is totally confusing. Following image is from Department of Art, Birmingham Young University, Idaho. All 3 of these photos show people in relation to the horizon line of the ocean. The subtle difference of where their eyes are relative to the horizon line tells us that the boy with the guitar is slightly above the viewer's eye level. The woman is right at the viewer's eye level, and the man in front of the boat is slightly below the viewer's eye level. Now that 8 inches per mile squared. You'd often get examples like, if you're standing on a beach in Florida or driving past the farms of Nebraska, both places where it's relatively flat, the farthest part of the horizon that you can see is about 3 miles away. Now, in my video debunking flat earthers' claim regarding aircraft and level flight, I talked about this equation in great details, including the origin. A quick summary is, this equation is in context of civil engineering, and the error margin gets higher as the distance gets higher. But for short distance, that error margin is acceptable at certain cases. Why do flat earthers still use this 8 inches formula? Well, the cynic in me says it allows them to find landmark that according to that formula should not be seen, but is seen in real life. Most often, using a more accurate formula would immediately debunk it. Finally, is there any other issues? Oh hell yeah! On my flat earther water level video, I explained the following in a lot more details. Both these equations assumes a flat level, where in reality, sea levels are different around the world, which is due to different gravitational strength around the Earth. We call this local sea level, and when we generally talk about sea level, we talk about global sea level, which is an average of all sea basins. Now, even with our equation, and even if the Earth was a perfect circle, you can still find a location where d distance away is water, and the calculated drop is, say, 10 meters. From that, we expect a boat 10 meters above water should not be visible. But what happens if the sea level over there is 1 meter higher than global sea level? Then we would see the top, right? There are even more issues. On the water finding level video, I also talked about refraction and Snell's law. Simply put, light bends as it enters one transparent medium into another. Next, we have water evaporation, and thus we have rain. Now imagine on a hotter day, more water are evaporating. So we can imagine the water molecules would be denser nearer to the water during this process. On top of that, we have other aberrations like dust particles in the air. Simply put, all these variables combined at times can produce an image which technically should be incorrect. There is an image flat earthers like to use called a black swan that perfectly demonstrates this. Finally, high-altitude amateur balloon footage without a fisheye or GoPro lens always shows a flat earth. Consider the image on screen. The first line in red. Well, we can immediately see the curve. Second line in blue? Well, it's less prominent. How about the third line in green? It appears flat, correct? But it is not flat. How do I know? Well, I created that image, and you're seeing part of it. Here is the full image, and you can see that all 3 lines are from 3 different circles. This is FOV or field of view. In context of photography, the field of view is that part of the world that is visible through the camera at a particular position and orientation in space. On screen, you can see the same photograph taken from the same spot, but using different field of view or focal length. As you can see, the smaller field of view is, the image is zoomed more, where larger field of view makes it wider. Simply put, if we want to include more of the scene, we would go with wide angle. And if we wanted to restrict what's on the scene, we would go smaller angle of telephoto lens. Now put this together. We need to see more of the circle to visually notice the curve. So on our Earth, we have to go up higher to see more of the horizon. We estimate we need to be at 10,000 meters high up with a roughly 60 degree of field of view to barely notice the curvature. And a clear sky over the ocean is a must. But if we have a lower FOV, we again do not see enough of the horizon. This is the main reason we can't really see the curve through a passenger window in a commercial flight. Furthermore, the design of those windows also distort the light. Which brings us to our next problem. Almost every lens suffers from optical distortion. There are three known types: barrel, pincushion, and mustache. A perfect lens without any distortion is very rare. A high-end lens would have lens elements to reduce it. When a sphere is projected onto a flat surface, image scale decreases away from the optical axis, and that is barrel distortion. For a system with simple lens and mirrors, this optical axis passes through the center of the curvature of each surface inside the lens. And the wider the lens is, the more prominent this distortion becomes. On screen, you can see a photograph where horizon is above the optical axis, i.e. center of the screen. Notice how the horizon appears to be curved. Next photograph, same spot, but now horizon is at optical axis level and appears to be flat. Finally, same spot, but with horizon lower than optical axis. Now horizon seems to be concave. It's not just point and click to get a picture of Earth's curvature. That brings us to a catch-22. We need to be high up and need to have a wide FOV just to barely see the curve. And then, the wider the lens is, the heavier this barrel distortion would become. What is one to do? Suppose you want to send a high-altitude amateur balloon. These things can go up to 30 km. Next thing to consider is a camera. Most prefer a small action cam like GoPro because these are lightweight, small, kind of weather resistant, and can withstand the cold temperature of the upper atmosphere. As the flight lasts between 90 to 180 minutes, you will also need to worry about battery, as typical action camera can only record videos for around 45 minutes with stock battery. A better choice by tech nerds is using a Canon camera with custom firmware. Also bear in mind that these balloons reaches only 8% of the altitude of ISS, and you'll only get to see 5% of Earth's diameter. Then comes lens. A fisheye lens is extremely wide angle. In fact, Sunex makes a fisheye that captures 185-degree field of view, where a normal GoPro's linear shot is around 102 degree. So option 1, get an aftermarket replacement lens for your action cam. These are hard to come by. Option 2, use something like Canon camera with custom lens. Or option 3, knowing the lens data and how much it distorted, we can correct this distortion in post-process. These are the reasons why most amateur videos you see uses action camera, and they're mostly concerned with the actual view and not to prove Earth's curvature. In worst case scenario, they would just fix it in post. Since different manufacturing lenses are different, lenses are tested in a lab environment to create what we call lens profile. Most post-processing software like Lightroom, Photoshop, Affinity Photo comes with a bunch of this profile and can be used to correct any photo given it has that profile. One thing to keep in mind though, the photo being corrected must have the same image center as the original photo. What I mean by that is, consider the photo shown on screen. We know the camera lens and can easily fix it. But if we are given only a part of the full image as indicated, well, the correction would be incorrect. So when the flat earthers say high altitude amateur balloon footage without a fisheye or GoPro lens always shows a flat earth, well, what they are really saying is, without a wide field of view, you always see a flat line, and technically, that is a true statement. At times we see them showing us a cropped image, which is essentially reducing the field of view to a point where it looks straight. I'm sorry if this was a long explanation. In summary, it is difficult to take photographs of Earth's curvature due to all the reasons I mentioned and more. If one is really after a photographic evidence, then pictures from ISS should suffice. The earliest documented mention of the spherical Earth concept dates from around the 5th century BC, when it was mentioned by ancient Greek philosophers. Funny thing is, they didn't come to that concept by sending a high-altitude balloon. Just because we cannot see a virus with our naked eye doesn't mean virus doesn't exist. Out of all things we consider, visual confirmation is really quite down in the list, once you understand how our brain assembles what we perceive. Well, that's all for this video. If you have managed to watch it so far, thank you so very much. I hope you enjoyed it and would give the video a like and maybe a comment to feed YouTube algorithm. If you could also subscribe for similar contents, that would definitely help my small channel grow and would be thoroughly appreciated. Have a safe day. Signing off.